All right, so we have the question epidemiology. And the question says, hold on, let me share my screen. Let me know when you all are seeing my screen. Yes?
Yes, sir.
All right, good. Right, so the question says, people who study epidemiology use models to analyze the spread of disease. In this problem, we use a simple model. When a person has a disease, they infect exactly R other people, but only on the very next day. This is an important part to note here for this question. All right, so they could only infect R other people once on the next day. No person is infected more than once. We want to determine when a total of more than P people have had the disease. There are 3 lines of input, so each line contains one positive integer. The first line contains the value of P. So this is P, and this line represents the point, the amount of people they want to know how long it takes to reach that amount of people in, right? So this is the target infection number, if I could call it that. Right? So that's the target infection number. The second line contains N, the number of people who have the disease on disease. So this is the number of day 0 patients. All right, number of day 0 patients. And then, of course, we have the third line contains the value of R, which is the number of people that get infected every day, right? So the number of people infected daily. And they say assume that R is less than this number would be about 10 million or something, so, and N is less than P, less than or equal to P, right? So N is of course the second. N can't be more than this number, right? N can't be more than that number, and R is less than 10, right? R represents what? The third line, right? And R means that no more than 10 people could get infected daily. So this has to be less than 10. This has to be less than P, and this has to be, right? So this is P, this is N, and this is R, right? And of course P is your target number. P has to be less than 10 to the power of 7. All right? So that's what they're asking here. So what it's saying is what we want to know is how long, the output here is how many days does it take to surpass this number of infections. So that's what the output asking, for the amount of days to surpass the target infection number. You understand where we're coming from with this? Hello? Hello?
Yes, sir. Yes, sir.
Right. Good. Okay. I need a dedicated yes person. All right. So
Go over
the
that one
one
more.
person, right? Okay, no problem. So the input based on the specification says that P is our target infection number. We want to know how long does it take to get to this number of people in, right? we have N, which starts with the number of people infected on day 0, and R is the amount of people that this number of people infects. Right? So this is so whatever R is multiplied by the amount of people in N. So if N was on day 2, it would have had 10 people in, right? So we go into the explanation. So we start on day 0. Day 0, we have 1 person infected. Right? On day 1, we have 5 new infections from that 1 person. So that 1, right? So let's say the rate that rate per person to infect is 5. So this 1 person will infect 5, will cause 5 new infections. So our total infections at this point is 6, right? This 1 person and the 5 new people they infect. And the rate for infection, these 5 people now on day 2 will cause 25 new people, because 5 by 5 is 25 new people to be infected. So 25 plus 6 is 31 persons infected by the end of day 2. Right? 25 multiplied by 5 will cause 100. Day 3 infections will cause 125 persons to be infected. So 125 plus 31 is how much? 6, 5, 156. Am I correct there? Right? And 125 by 5, day 4, right? So this is new infections, basically. Day 4, new infections, we'll have 625 new infections. 625 and 156 is 781. 781 is greater than 750. Not so? Right? 781 is greater than 750. So on day 4, we've reached our target infection so that we know how fast everybody's getting infected. You all understand where we're coming from with this? Let's do it again for the sample input 2. All right? So for the sample input 2, our target is to know how many days it will take for 10 people to get infected. So this is our target. And we want to know how many days it will take. On day 0, we started off with 2. So the total number of infections were 2. But the rate of infection in this case, is 0.5. Right? It's 0.5. So it takes basically 2 days for 1 new person to get infected. You understand where we're coming from with this?
Yes, sir.
Okay. So on day 1, right, half of the amount of people get infected here. So on day 1, we get 1 new infection. So the total is now 3. Right? The total is now 3. On this person is going to take, this person now is going to take 2 days to infect 1 new person. All right? This is going to take 2 days. Let me work out. Let me just make sure I'm doing the right thing here. All right? On each other day, exactly 2 persons are infected. So let me work with this. All right? We have 2 people on day 0. We have 2 people on day 0 with infected. So our total is 2 at this point. right? They say here, essentially, on each other day, exactly 2 people are infected. So let me. All right, they want us to work with integers alone, I suppose. All right, so 2 people, each other day, 2 people are infected. Makes sense of this. Number of day 0 patients, number of people infected daily. Wow. All right, yes, because we say that this number represents the number of people infected daily. So each other day, exactly 2 people are infected. So let's say, if I'm going with what they're saying, day 1, right, we had 2 people each infecting 1 person each. Right, yes, that makes sense. We just like how we had everybody, each 1 person infecting 5 people, right? And each day, these 2 people would infect 1 person each. So 2 people, right? So this is your infection per person, which is 1. But it started off with 2 people. So what happens is that these 2 people will infect 1 person each. So on the first day, right, two persons, right? So that's how come you get
breaking up.
2 by 1 persons, so that you get your 2 persons infected on day 2. Yeah, Hazard, I hear you. Is it any better now? Hello?
So I mean, you stop here now, so let's we'll come back. But again,
Yeah,
like I don't know if it's just me, I get some kind of fuzzy thing on the stream popping up every now and then. I don't know
hold
what it
on.
is.
Yeah, I tell you, I apologize. My internet today is under pressure.
It's not, yeah, it's not.
All right. So, but each day, the number of new infections will infect 1 person each. So 2 by 1 again will give us the 2. This will give us 4 people, right? The 2 will be 2 new people, right? So now we have 6 people. These 2 people will infect 1 person each, so that we have 2 people on day 3, right? On day 3, and of course our target is 10. Right? So on day 3, 2 new people will get affected, right? Those 2 new people will then affect 1 that would have carried it up to 8, right? And on day 4, 2 people would have been affected, so that would have carried it up to 10, right? So, and by the end of the day 5, more than 10 people had the disease. So on day 5, 2 new people would have been affected, so that would have been 12, which would have surpassed our target.
So our quick question, sir.
All right, so forget about what I was saying with this 0.5. I understood it wrong here. So I'm taking off this. Yeah.
Yeah. So you could just I was thinking if you could make it into a mathematical formula, so like you
Um.
see how in the first one when it was
Mm-hmm.
like yeah, in the first one it was like 5 and when it was 1 person on day 1 and they was affecting 5 people each and you wanted to find the amount of days, so I was just thinking if you put like 5 to I don't know, like I was just thinking like if you put 5 to what power in a sense and just multiplying by 5 and 5 again, that would
Mm-hmm.
surpass 750. I was thinking if you could do it like that.
Let's see. Yeah, in a kind of way, because it's an accumulation of so that's a decent way to put it. right? And that's actually a very nice way to put it. So on day one is 5 to the power of 1, right? 5 to the power of 1 plus 5 to the power of 2. So the original value, which was 1, plus 5 to the power of 1 plus 5 to the power of 2, right? Plus 5 to the power of 3 plus 5 to the power of 4. And that will allow you to surpass that 750, right? So yeah, so this is kind of like your formula if you think about it well, right? So let's see if we do it the same way, right? So we saying 10 is less than or equal to, no, less is less than, we don't want it equal to, all right? So 10 is less than the 0 value, which is 2, plus 2 to the power of 1, but every day it's 2 to the power of 1 in this instance. You know, so we will have to figure out, you would have to figure out the way to differentiate when this kind of accumulation here versus this accumulation here. You understand what I'm saying, Joshua?
Yeah, yeah, I think that's what I'm saying.
But that's simple to do. That's kind of simple to do in a bit of a way. We thinking through here. We thinking through here. So let's say, for instance, you had 750. The original n was 3 and the original r was 5. Is it that you multiply this value by 3 every day now too? How you get it? How you coming up with that? We talking it through, eh? And how many of you all doing maths inside? How many of you all doing maths inside of here? All right. You don't apply it up here, eh? Just 4 people. That's a pretty low number for a ComSci. All right. So the mathematical thinkers, let me see. You all take a mathematical approach to this. This is probably a question you could carry to your pure maths class, and you all could see if you could come up with some, and even applied maths, because applied maths have some algorithms in it. So what are we going to do to solve this question?
So I got something for the first one. So you see, I was just thinking 2 to the power x plus, if you're talking about the second example, plus 2 to the power 1 should be greater than, was it like 10? So that was just like 2 to the power x is be greater than 8. So that's 2 to the x equal to 8. So 2. But that was not really 5 though. I mean, that's just greater than 3, because 2 to the power x is equal to 2 to the power 3, so x equal to 3, so that will just be greater than 3. So but is what we're seeing is 5 this here, so I'm wondering.
I don't think I don't think I followed what you said. I apologize. All right. My approach to this, especially from a programmer's perspective, and I will be honest with you guys, my mathematical background is not super strong, is to take it as I see it in terms of the consideration. So what they gave you was the first scenario where the number of day 0 patients was low, but the infection rate is high. And then you have the second scenario where the infection rate is low, but the number of day 0 patients was higher. And what I would do is I would approach this by trying to taking a look at solving it as it exists there, right? In this scenario, this first scenario, and then seeing if that applies to the second scenario or if I have to do anything special for the second scenario. You understand where I'm coming from?
Yes, sir.
All right. So I say let's take a crack at it from just the simplest possible perspective, right? Which is just taking into consideration this scenario, and let's see if we can get the numbers to match up like this, because this is just basically an accumulation of numbers, right? It's an accumulation of numbers, and you just have to figure out, okay, do I have to multiply in this particular scenario, or do I have to do an exponent maybe? All right. All right. So
that was a question.
no, what was that? No, that was not a question. That was me getting a message from school, so I got a little distracted. All right. So let's go with it and see how we can approach solution to this. All right. This was 2020 CCC question. Right. So we have 3 lines of input. So let's just set up for our 3 lines of input. Right? We know that we have int p, we have int p, we have int n, and we have int r. Okay, and we know that we've been given some ranges that these values are not supposed to exceed. All right. So we could go scanf, and I'll show you all something in terms of verifying these values here. Percent sign D, percent P, sure. And our specification says that P is not supposed to exceed 10 to the power 7, right? Just go in, 10 to the power 7. It's 10 million. Yes, I was correct. Right? So we could say here that if P is greater than or equal 10 to the power 7, right? Then you could exit 0. And exit 0 simply means leave the program. Right? Stop program execution. Okay? So if P is greater than 10 to the power of 7, all right? So get the value of the target for infections. So we get the value for the target for infections. And then the next thing that we want to get is the number of people who have the disease on the day 0, right? So we go scanf, right? Percent sign D, and we store that in N, ampersand N. This is the number of people who have the infection on the 0. And the fact that they count us with day 0, that tells us that maybe we need to have a counter for day, right? Because every day we are working out, because we want to really and truly print out the value of the day, when what date is when the p-value gets exceeded. Agreed? Okay, so we have the number of
Yes, sir.
people who have the infection on day 0, and we know that n is not supposed to exceed the value of p. If n is greater than p, what do we want to do? Exit 0. And it's important that we include this, right? If n is greater than p, stop program execution. Because this was specified inside of there, right? And we say the third line contains the infection rate, right? R is the amount of people who get infected per day, per person, right? So we say scan F, and you see why sometimes two comments are important for your own self, right? So %sign D. This is the rate of infection per day per person. So each person is supposed to infect 10 or less people. And they said again, we say if R is greater than 10, because they said that R is supposed to be less than or equal. So if R is greater than 10, we exit 0. So we've started off with the inputs. We've gotten the value if R greater than 10. Stop program execution. Okay. So we've gotten the value of for all of our inputs, and and we know we've gotten the rules for the numbers that we have, and we want to now start to work out day by day what are the new infection numbers. So we say totals, right? Total, right? Or tot underscore I for total infection. And as it is day 0, we know for a fact that total infection, right? Tot underscore I is equal to the second value that we entered, is equal to n. So what we are saying here is on day 0, the total infections is equal to n. Anybody have any questions about what I've typed out so far? On day 0, the total infections is equal to n. Right? And that's correct. But we want to keep an accumulation of new infections as they arise. We want to keep an accumulation of new infections as they arise. So what do we know? That the one person on day 0 is then going to infect 5 people on day 1. How do we represent that in terms of our programming? Right? We could say while what? This is a while loop question. While what? What is our criteria for stopping?
So while I think what I see the population or something, the infected people is less than the population.
Less than the target number.
Yeah, the target number. Yeah.
Right? So while what is the total number of people? While tot underscore I is less than the value of P. And I had a incorrect thing here. I had common P, it's supposed to be a capital P, sorry. So while total infections is less than the target value, what do we want to do? We want to let the days go by and see how it goes up day by day. So we're still on day 0 here, right? But what happens on day 1? So we have day and we have total infections being equal to the value of n, right? And what happens on day 1? That n value will infect a new amount of people, right? So we have the number of people who have the infection multiplied by the number of people who could be infected every day. That's n multiplied by r, right? So we have n multiplied by r being added to the infections daily, right? So we could have, okay, we can name this new underscore infections. New underscore I is equal to n multiplied by r. So we could say calculate the number of new infections today, right? Calculate the number of new infections today. And based upon what we were given inside of our specification, where we said, okay, on day 0, person was infected, but by day 1, 5 new people would be infected. It means that the new infection is now going to be the number of people that were infected multiplied by the rate of infection. So the new infections is going to be that 1 multiplied by 5. Everybody good with where I'm at? And any questions thus far?
Sir, I don't understand when you say new infections.
You don't understand when I say new infections?
No, sir,
Every
I understand when you say new infections, but is it but is near the end when you say the new infections would be multiplied by the
rate.
rate.
So the number of people infected, right? The number of people infected from day 1, from day 0, they are going to infect a certain amount of people, right? So in this case, we have one person infecting 5 people. So the new infections at the end of day 1 is going to be 5, right? And this will happen on the first day, right? So we could say now, if day is equal to 0, we work out the new infections, right? On the first day, calculate the new infections, the new number of infections today. And that is from the original number of patients on day 0 multiplied by the number of people they should infect. Okay? However, right? However, on every other day, the new infections will create new infections. So we would say new underscore I is equal to new underscore I multiplied by R. That's not an R, that's a T. Okay? So on the original day, we could have a certain amount of people infecting the new amount. But after that, we have to say the new infections will be now how many people from yesterday multiplied by the rate of infection. And every day, we want to carry the day value up by, so day plus plus. And we also have to keep a tally of the total infections. So we say total underscore infections, carry the day up by, right? And we say total infections is equal to total infections plus new infections. So on the first day, the number of people that we could calculate, we calculate is based upon the original amount of people. But from the second day, the new infections is what the new infection number is what will determine how fast the going to spread. Okay? So increase the total infection count by the new, right? And once this has happened, then you print out printf, right? Once you've passed the threshold, so while the total infections is less than the what did I call that? The target. Right? You continue to add and research and see how fast you're infected. And only after you want to print out the value for the right? So once you've gotten to your target infection number, once you passed the target infection number, you can print out the days. All right, so once you pass the target infection number, you can print out the days. Let's test this and see how it works. Right, I have an error here. Oh, sorry, I have two brackets. What else do I have here? I have a missing semicolon. Okay, so let's test it with their numbers, right? 750, one, and that one person infects 5 persons every day. After 4 days, we will have gotten to the point where we can come out. So it's the same thing that we said. Let's test and see if the same method would work with the second sample input. Because I mean, it's the same rate of infection that, right? We're looking to see when 10 people get infected. 2 persons started off with the infection, and those 2 persons are infecting 1 person every day, right? I have 4 coming out here. So I have some issue with that, with those figures in terms of the sample infections because it's 5, right? They got 5. So while total I is equal to P. Oh, yes, I think I know where my issue lies with the second day. Right, and each other day, 2 people are infected. By the end of day 4, a total of exactly 10 people. Right, this should be while total I is less than or equal to P. So if I try with my figures again, for the second sample input of 10, 2, and 1, I get the 5 days. Because it's only when this exceeds the value should I consider the target passed, right? So while the total infections is less than or equal to the target. So we didn't have to do any sort of fancy maths to get there. we really and truly use logic, pure logic, to see at what point we should surpass the infections. Jude, are you with me on this? You understand where I got these values from and why I made the distinction between day 0 and every other day?
Well, I'm not too. I, well, from the way that I see it, when you, to get the first day, you have to get the first day, you have to do something weird, and then for the second day is something
Every other day.
continuous. So I understand with every other day.
Yeah. So the first day we started off with one person, and that one person. So this was day 0, right? And we want to see how many persons this one person infected here. So we have 1, 2, 3, 4, 5. And we see that they infected 5 people. So really and truly, this total I, because we started with total I being 1, total infections was this on day 0. By the end of day 1, right, or at the end of day 0, going into day 1, our total infection was this person plus all of these people, right? That's what so day 0's infections will end, that one original person, right? We say if day 0, we have to see how much that original value of people infect. And then on every other day, we can't use that original value because the value has already changed to this here. So this new infection here for every other day is where we're using this to create this new infection value. So at the end of day 1, each one of these people, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. You understand where I'm coming from? And that's why I made the distinction here. Because on the first day, only the original value people. But on the second day, you have to consider all of the new people who were infected as a result of that original person. So the first day is kind of special in this case.
Yes, I understand it better.
But do you understand it completely? All right? You understand it enough for this to make sense to you?
Yes, sir.
All right then. All right. Anybody has any other questions? I hope that this encourages us to, because you realize the algorithms are not difficult, yeah? They just require a lot of thought. So I hope that this encouraged us more towards wanting to do the computing examination. And I can assure you that if you are able to do this computing examination, whatever they ask you for CAPE is going to be food. Right? Because at the end of the day, you know, this computing examination, the questions are, I would say, a little more challenging than what CAPE could ask you. There is no penalty to not doing well in this computing examination. This is kind of like a self-test. So, you know, I would encourage you to really go forward and try and attempt this, you know, because it's something that I think will only strengthen you as a programmer, especially for those of you who want to. Yeah.
So I would like to do it. That's a good idea. I just don't think I have the fundamentals down pat good enough to attempt it as yet.
Well, that we will take time. We will agree on. I know that it's only about 15 days, 2 weeks. I think if we take half hour to 45 minutes, 3 or 4 times a week, you should be able to at least be able to attempt. And when I say half hour, I will work with you guys. on that, right? For half hour to 45 minutes. Every day we take a question and we attempt it. And that is, from now till the 17th when it's due. But I have to know, let's say by the end of this week, or maybe let's say Thursday, if you are ready, if you really want to register. Because I have to get all of the registration information in and all of that. All right, so I'll put up a post where I could get a name for people who are interested. I will close off that post on Thursday. But if it is that you guys are ready from all now, I am willing to spend a half hour, let's say or let's say I'm willing to spend from 11:30 to 12:15 every Monday to Tuesday to try and work with you guys to prepare you for this specifically. And if you all want to start today, I can start today. And I have radio silence. Maybe I should stop the recording at this point.